Hello, today we will be covering distance and midpoints, lesson 1.3. By the end of this video, you'll be able to find the midpoint of a line segment in the coordinate plane and measure the length of a line segment in the coordinate plane. We're going to go ahead and skip this 5-minute check. If you want to pause and try it, you can. Our new vocab is distance, midpoint, and segment bisector. So the distance formula on a number line is a little bit different than the distance formula on a coordinate plane. The distance formula on a number line is the distance between 2 points is the absolute value of the difference between their coordinates. So you'll notice here we use x1, x2 instead of numbers, and that we have our absolute values to write them out. Let's go ahead and try one, so you can see how this works. So we are finding the distance between Q and R. Now notice it doesn't say to find the distance. When you have QR here without a line on top, that signifies that you are finding the distance. So we take the absolute value from -6, and then notice we subtract them. So we take -6 minus a -3, and minus a negative becomes a positive. So -6 plus 3 is -3. And the absolute value is just the distance away from 0, so the absolute value of -3 is 3. We'll go ahead and say units, and that is the distance of QR. And on these ones, it's easy enough just to check 1, 2, 3. It is 3 units away. Okay? We'll try another one. We'll take and find the distance from A to X. As I said, you can just count. We have the absolute value of -5 minus 3 this time. So -5 minus 3 is -8. The absolute value of -8 is +8 units. And that is the difference of distance AX. Count 2, 3, 4, 5, 6, 7, 8. And that checks out. The distance on a number line is pretty easy. We're going to skip this slide and go ahead and look at distance in a coordinate plane. Now we are going to dig a little deeper into this distance formula. I'm going to ask you to have this distance formula memorized, but this next part we're going to go through on how to find the distance formula. You don't have to memorize. So you'll notice we once again have P and Q written as undistinct coordinates. They're not numbers. They're just general. And that's how we end up proving things. So this is how we came up with our distance formula. We're going to go ahead and create a triangle and call a point M. Now M, we need to know the coordinate of M. So we know in our X side, we went over to the right the same amount as we did for Q. So X2 is our X value. And we went up to M the same amount as we went up to P. So our coordinate for M is x2, y1. Now we're going to use the Pythagorean Theorem and our distance on a number line to derive our formula. So our Pythagorean Theorem, a squared plus b squared equals c squared, we're going to use that. We're also going to use the idea of distance on a number line. So for now, we're going to worry about our x1, x2 on this line here. We're going to pretend the rest of the triangle doesn't exist. To find the distance between these, we take the absolute value of x1 minus x2. We'll call this line here A. To find the distance between Q and M, we're going to use our y values, y1 and y2. And as we did on the last problem, we take y1 minus y2, and we're going to call that guy b. So if this guy equals a, and this guy equals b, like it would in our triangle, we can go ahead and plug these into our Pythagorean theorem. So we have the absolute value of x1 minus x2 squared plus the absolute value of y1 minus y2 squared will equal c squared. Now, the reason why our actual equation doesn't have absolute value symbols in it is because when you take the square of any number, it always has to become positive. So it works similar to absolute values, and that's why we can go ahead and get rid of them. Okay? One last step here. We have to get c by itself to find that distance, so we take the square root. So our solution is the square root of x1 minus x2 squared plus y1 minus y2 squared. And that equals our distance, in this case, PQ. You can also call it C. So we have found our distance formula by using the Pythagorean theorem and the distance on the line segment. Now notice, these two are slightly different. The only difference is that on the first one, our x2, y2 comes first within our parentheses. It honestly doesn't matter. Either way works. So just choose the one you want to use and you're good to go. Let's try it out. I'm going to go ahead and copy this down here. Erase that guy. All right. So I like to, even in college, go ahead and mark out what my coordinates are so I don't get confused. So I'm going to call this x1, y1, x2, y2. Where I see my x1, I'm going to plug in -4. Where I see my x2, I'm going to plug in 3. Notice this this subtraction stayed here. These will stay. I would leave them on your first step at least. Then where I see my y1, I have 1. In my y2, I have subtract a -1 squared. So this sign here will change to positive. The 1 between the -4 and the 3 will stay as is. So we bring down a -7, because -4 minus 3 is -7 and squared. 1 plus 1 is 2. Square it. And then we take the square root of these. Now, -7 times -7 will equal positive 49. So keep that in mind down here. 49 plus 4. 2 times 2 is 4. Our solution is then the square root of 53. We can go ahead and say units for the distance EF. Okay? You can go ahead and leave it like this, or you can switch it to a decimal. Either one is okay. Let's try another one. Same thing, we have the distance formula. Paste it in here. I'm going to label my coordinates x1, y1, x2, y2. Replace them. x1 is -3 minus 1 squared plus 4 minus 2 squared. Simplify within my parentheses. Negative 4 squared plus 2 squared. Negative 4 times negative 4 is 16. 2 times 2 is 4. 16 plus 4 is 20. And we should probably write units. And that is our distance from A to M. I want to show you real quick that by doing the Pythagorean theorem, we would get the same thing on our graph here. So I created a triangle. The distance to our right angle is 2. And 4 here. So we have a squared plus b squared equals c squared. So 2 squared plus 4 squared equals c squared. 4 plus 16 equals c squared. 20 equals c squared. Take the square root. So c equals the square root of 20 units. So either way we do it, we get the same solution. That is a good thing, because if we didn't, we would have messed up somewhere. Check. All right, you'll notice we used to do this in 2 days. We're going to go ahead and continue to midpoints. The midpoint formula on a number line is basically just taking the averages. So segment AB has endpoints x1, x2 on a number line. Then the midpoint M of AB has coordinate x1 plus x2 divided by 2. This is our averages. All right, another thing. Midpoint cuts our segment in half. So these two pieces, AM and MB, are congruent to each other. This is called a segment bisector. So when it's cut in half, that is a segment bisector. So let's practice finding our averages. So A is negative 3. We always use addition when we average, so negative 3 plus 5 divided by 2 is 2 over 2. That reduces to 1. We can go ahead and check it out. We go 1, 2, 3, 4. 1, 2, 3, 4. That is our average. So 1 is our midpoint. We also have our average for number 2. Negative 2 plus 3 divided by 2. Well, negative 2 plus 3 is 1. Divide that by 2 and we get a half. We can check it by counting again. So 1, 2, and a half. 1, 2, and a half. So a half is our midpoint. Okay? Now if we do it in a coordinate plane, we just do that twice. We find the averages of our x's, our x values. We find the averages of our y values, and we label our point, in this case M, with the letter in front. So we're going to find the coordinates of M, the midpoint of GH. So we are going to find the averages of our x's, the averages of our y's, and label it M. So we have 8 minus 14 divided by 2. We have negative 6 plus 12 divided by 2. Now when I said minus 8 minus 14, I meant plus a negative 14, just so you don't get confused. Go ahead and simplify. So we have negative 6 divided by 2. We have 6 divided by 2. We divide these out, and we have negative 3 as our midpoint. Now I want to point out a couple things here. Midpoints have the point labeled in front of them. Coordinates can be negative. And thirdly, include our parentheses on your homework, or else I'll count off half a point. That's the correct way to do them. Okay? I believe I said it up top, but the reason I'm pointing out that coordinates can be negative is distance cannot be negative. If it's negative, something went wrong. So we're going to go ahead and find the coordinate of the midpoint here once again, keeping those three things in mind. Find the average of our x values. Find the average of our y values. And they didn't name our midpoint, so I'm just going to name it M again. So we're finding the average of our x values, negative 2 and negative 8. And our y values, 3 and negative 9. Go ahead and simplify each separately. And then divide. And that is your solution. All right, now this time, the next two problems. We are given a midpoint and our endpoint, and we have to find our other endpoint. So, if you recall, we have our equation, x1 plus x2 divided by 2, y1 plus y2 divided by 2 equals our midpoint coordinate x comma y. So now if we read the problem, find the coordinate of D if E is negative 6, 4, the midpoint of DF, and F has coordinates negative 5, negative 3. So we're given the midpoint this time. We're going to plug him in. And we are given one of our endpoints, which means we can plug it into a section of each of these. And now we are going to treat these as two separate equations. We have the equation for the x value of our missing endpoint and the equation of a y value for our missing endpoint. So we go ahead and solve for each of these. I set up my x's. I set up my y's. And then I solve. I try to get my x value by itself on this first one. So I multiply 2 on both sides because I want to get it out of the denominator. And then I will add 5 on both sides. So our x value for our end point is -7. And our y value, we'll do something very similar. Will be 11. So then last thing, make sure you just write out that we are finding D and its value is -711. Go ahead, try the next one on your own. Hopefully you were able to figure that one out. All right, now here's where it comes in that these are segment bisectors. That means PQ and QR are congruent when Q is the midpoint. And we are going to find PR here. So PQ is the same as QR, 6 minus 3x. So we can go ahead and take 6 minus 3x plus 6 minus 3x and equal that to 14x plus 2. Combine like terms. Solve for x. Some of your homework assignments will have decimals or fractions, just like here. X equals half. I'm not done yet though. I need to plug that in for x and PR. So 14 times 1/2 plus 2, or 7 plus 2. So 9 units is PR, the distance of PR. Okay. This last one is similar. Once again, AB and BC are congruent. So you go ahead and set up an equation. You add left segment plus right segment equals whole segment. Combine like terms. And then solve for A. This one will finish with a whole number. And go ahead, we are finding the measure of AC, so plug A back into AC. So 9 plus 1 will equal 10, so AC is 10 units. If you have any questions, just ask me in class. I can go over it again with you.